Assalamu alaikum warahmatullahi wabarakatuh. Hello everyone. This is Sumaya Hassan. I will today do a presentation in the operating system. I will do a comparison between a classical operating system and the quantum operating system. What is the differences? Why quantum operating system is more important? And what is the feature between them? How can the quantum computer organization systems help us in the future and in medicine and biology in the future learning and in faster jobs? So let's go. So starting with the comparison and differences, key differences between classical OS and the quantum OS. So to look here at this comparison, it says that in the classical operating system, for example, Linux and Windows, and the quantum operating system QoS, in the classical, based on classical bits, which can be in one of two states, zero or ones. In the normal computers, as we know and we learn, the binary qubits like zeros and ones. It's the normal things that you can find out in any computer. But in quantum, there is something weird. It's not zero or one, but it's zero and one at the same time. For example, if you throw out a coin in the air and this coin is like dribble and dribble and dribble in the air, you can find out that it's head and the tail at the same time in the air. You can't say it's head or tail. It's like run fast and change his state fast. So you can find out it may be the two things at the same time. And when the coin is be on a state on the ground, maybe it will be head or tail. But in the state of running, he is the both. So it's the same of quantum computing. So quantum computing operating system based on quantum bits, qubits, which can be in a superposition of zero and one, enabling parallelism. Also, it manages for classical operating system manages memory, CPU, storage, input and output resources. But in quantum, it managing quantum resources, specifically qubits, including entanglement, coherence, and measurements. For classical, the multi-threading and multiprocessing are used in the parallelism, but in quantum computing naturally handles concurrency through superposition and entanglement. And also in the classical in the classical OS, classical error handling techniques, for example, retries and exceptions, but in the quantum deals with a quantum decoherence and noise using quantum error correction algorithms. And this is so much better because in the classical, you can imagine that there is a library and you have a book and this book have a security code and you want to find out this security code. So in classical, you will open every book and search for the word or the code that you wanna find out and you will match them. But in fact, the quantum computing, he will open all the books at the same time and find out the code that you wanna take for in 1 second or in less time than the classical and much faster, and he will give you the code that you want. So this is the difference between them. And for classical, also traditional algorithms run sequentially or with parallelism, but in quantum algorithms utilize quantum phenomena like superposition, entanglement, and interference for faster problem solving. And This is the same things that I have discussed about the library and books. Also, last thing in this comparison, um, in the classical integrates seamlessly with classical hardware, but in quantum needs integration with classical system to function hybrid models, as quantum computers are still limited, because his physical state is not stable, like zero and one at the same time, and you can't find out it's positive or negative, it's zero or one, its change is faster. And here at this slide, we will discuss the quantum operating system components and how they are handle key aspects. So in the classical OS scheduling, we will see here that the classical operating system manages tasks by allocating CPU time to processes or threads, and the schedule algorithms like round robin and the priority scheduling, or multi-level feedback queues decide the order of the process execution. In the normal OS, he do scheduling and they take a process one at a time and do the priority and schedule the time of the priority processes and try to find out which one will do first and then order them to give you the best thing that he can. But in quantum, there is a surprise. It's way much better. In quantum systems, the scheduling involves the efficient allocation of qubits to quantum operations, quantum gates. The quantum scheduling must ensure that the qubits maintain coherence and aren't lost due to decoherence because the computation completes. Since the quantum operations are inherently parallel, and the QoS schedule must manage the qubits entanglement, gate operations, and measurement protocol efficiently. And of course, there is challenges. So in the classical scheduling involves dividing time among processes and ensuring responsive and fairness. Yes, because for example, if you will search for a book in the library or try to solve like a chess game, you will try to find out every way to reach your goals, and you will process the time to reach out every goal. Or if you are reading books or try to find out something in one book, you will go for every book and take time to open every book and search in it. But in quantum, it's not. He is not taking the same time because he do all at the same time. He open all the books at once. He try all the goals at once. So in quantum computing, the complexity comes from quantum entanglement and the coherence, which are fragile and can be distributed easily by an environment. And let's see about the security. So the security in the classical OS security relies on techniques like encryption, AES or RSA, access control, firewalls, intrusion detection systems. Also, these systems secure data stored on the classical devices and ensure that the confidentiality, integrity, and availability of the information. But in the quantum, security focus on exploring quantum cryptography, and this is one of the most features that the quantum give it to us. For example, quantum key distribution or QKD, what is the quantum principles like Heisenberg's uncertainty or principle ensure that any i- um, ensure that any yeah Yeah, we are here. So the quantum principles like Heisenberg's uncertainty principles ensure that any dropping attempt on quantum keys can be detected. Like there is no loss for data. Everything can be detected, and any dropping, he will find out a way to reach for it. So the quantum OS must also manage quantum error correction for maintaining quantum states and preventing unauthorized access during computation. Uh, yeah, so here as you can see, he must also manage the quantum error correction. So he reach out for the correction and manage it, and he and by this way he prevent any unauthorized access to the computations. Like anyone have a data or his personal information, no one can reach out to it by it. Let's see for the challenges. So the security in the classical one can be robust and well understood. This is the challenges, but in the quantum security protocols needs to be safeguard against the quantum attacks and manage quantum entanglement, which can be pose a new threat vectors. Let's go for the memory now. So the memory in the classical OS uses virtual memory paging and segmentation to manage the physical and virtual memory on a device. And also it ensures that the process can access the memory resources even if they exceed physical RAM capacity. But in quantum, the quantum memory management is far more complex because qubits doesn't store information in a conventional way. The quantum memory must handle quantum states because they are zeros and ones at the same time, so they have to handle the states, which are susceptible to decoherence, the loss of the quantum information. The quantum memory management involves sta- stabilizing qubits and ensuring that the quantum information is preserved throughout the computation process, often requiring quantum error correction to handle errors. So they tried their best to see the states of the quantum and to try to correct errors and handle it to do their best in the memory. For the challenges, classical memory management optimizes storage and relative processes. But in quantum memory management, must deal with non-classical nature of qubits, which can exist in superpositions, entanglement states, maintaining coherence in the quantum states, while performing calculations is one of the biggest challenge. Yeah. So while his state from zeros to ones is changing faster and faster and faster, he has to like deal with this non classical nature, and he has to do deal with the states of the coherence of it and of the performing the calculation. And this is one of the biggest challenges because they can't control the changing of the states, or it's zeros or ones at the same time. For maybe this is the last one for classical OS application handling and for quantum OS application handling. So let's see. At the classical one, a classical OS handles application by providing processes and threads. It ensures that the resources allocation and the execution of the application based on the priority or user input. So they make sure it's based on the priority or user input. Applications are written to run on the classical computation hardware and access system resources. But in the quantum application are written to take advantage of quantum algorithms, and this is the best thing that you can ever think. For example, like Shor's algorithms for searching, for factoring, and Grover's algorithms for searching database. And these applications run on quantum hardware and involve quantum operations like quantum gates, superposition, and entanglement. A QoS must manage the quantum resources necessary for for these operations, including qubits initialization, quantum gates operations, and measurements. And let's go and see about the challenges. So in the classical one, the application typically follow a sequential and parallel mode of execution. But in the quantum application, however, involve quantum phenomena that require careful orchestration of quantum gates and interactions. The quantum OS must handle both classical and the quantum parts of the application, especially in hybrid quantum classical applications, where the parts of the program run on the classical computers and the parts on the quantum computers. So there is two parts. One can run on the classical applications, and the other part of the application can run on the quantum computers. And this is a most like good feature because they make the easy part to run on the classical one because we don't need that much of the quantum here, but on the other part that we need faster processes and complicated ones, we use the quantum. Put this part of the application on the quantum computers, and gives us the best results ever. So let's see about the operating systems, quantum operating system types. So the quantum operating systems, QoS, are still in the early stage of development, and various types are emerging to handle different needs in quantum computing environment. Some of the most prominent QoS types include. So there is some types of it. So let's see. First one is IBM Qiskert, which is a software development kit and the quantum computing environment that enables the quantum algorithms development and the quantum circuit management. Also, it interacts with IBM's quantum processors and provides tools for quantum simulation and error correction. My second one is Microsoft Quantum Development Kit, QDK, which includes the Q language, quantum simulators, and integrated development environments, IDEs. And also, the QDK is designed to develop and simulate and execute quantum application efficiently, with a focus on scalability and quantum error correction. There is the third type is Google Crack, which is a Python-based quantum computing library for developing quantum circuits and algorithms. Also, it designed for use Google's quantum processors and focuses on scalable quantum computing. The last two, Quantum OS, which is used in research projects. A project aimed at developing on open resources quantum operating systems. Also, it explores how to integrate quantum computing with a classical system and provide modular approach for quantum algorithm development and execution. Last thing, the parity QC. A quantum OS aimed at optimizing quantum algorithms and resources across quantum hardware. Parity QC aims to improve the performance of the quantum operations and error correction at the scale. The conclusion. So here is the conclusion. Let's go. Conclusion of the classical V is the quantum OS. In the scheduling, classical OS schedule tasks based on the processes and the threads, while QoS must manage the fragile nature of qubits and the quantum entanglement. So on the classical, it's okay and good to go. They have to just manage the tasks based on the priority and which one will come first. But in the quantum, they have to manage the fragile of the nature of the qubits because it's zero and ones at the same time. In the security, classical OS relies on the conventional encryption, whereas the QoS uses quantum cryptography, and this is the good feature, like quantum key distribution to secure communications. In the memory, classical memory manages manages management relies on traditional techniques like paging, while quantum memory management focuses on maintaining the coherence of qubits and error corrections, and this is a good feature. Applications. Classical applications are executed on conventional hardware, whereas the quantum application require quantum gates, entanglement, and measurement, often required hyper-classical quantum solutions. Finally, and I am very glad that this is a finally, quantum operating systems are still evolving. But there is development will significantly impacting industries like cryptography, optimization, and machine learning by leveraging quantum parallelism and entanglement for solving problems that are interactable for classical systems. I hope all you guys will enjoy my presentation, and I hope the goal of the quantum computer is to be as classical or OS reached to you, and how much it's the quantum different nature, and it's it's like give us some features, and also it have some challenges. It help us in some fields, and it help us in the big data, and we can take advantage of it in a lot of things. And we are great and happy that this thing is invented, or they like find it out, and it will help us a lot in the future. Thank you guys. Have a nice day. I hope Dr. Iman will enjoy this presentation, and I am so sorry for any late, and I hope everything will be okay. Bye.